Hi there, I'm Tom Hoskins, editor of Mining Journal, and I'm here with Ryan Melsert, who's the Chief Technology Officer at American Battery Metals Corporation. Ryan was the former Research and Development Manager for Tesla's Gigafactory Battery Materials Processing Division. During his time at Tesla, Ryan founded and led a cross-functional team of mechanical and chemical engineers who implemented first principles design to develop novel first-of-a-kind systems for the extraction, purification, and synthesis of precursor and active battery materials. His background is in chemical engineering, also with a business degree, and he's focused his career on developing first-of-kind technologies. So Ryan, American Battery Metals Corporation is really focused on the process of deconstructing batteries and recycling batteries, but also on the extraction of primary metals. But I'd like to start off talking a little bit about the recycling side of things, because it's not something that we've covered much at Mining Journal. Could you talk a little bit about your technology and how it differs from current technology in the market?
Yes, of course, and thank you for having me here. When you look globally as far as the recycling of lithium-ion batteries, the vast majority of existing facilities operate in Asia and specifically China. And they tend to use very similar technologies where they will take an entire battery pack or a module or cells and put it through a high temperature furnace essentially to oxidize many of the liquid organic carbonates within the battery cell, to oxidize many of the carbon graphite anode materials, and to essentially make the battery inert and easier to process downstream. But that's a relatively expensive system to operate. It puts large amounts of pollutant emissions in the air. The species of fluorine and phosphorus can form very polluting and toxic materials that then need to be scrubbed out of that exhaust stream. And downstream, the materials are sintered together, and it makes it much more difficult to separate them in physical manners. And if you go through a conventional smelting pathway, it makes it difficult to recover each of those elements in high recovery efficiencies. So because of that, many of those facilities throughout the world don't operate especially profitably, or they actually need to be paid a tipping fee to be paid to take waste material away from companies or consumers. And because of that, it really puts a disincentive on those materials from re-entering the market to really make this battery supply chain system a closed loop. So what we've done differently at American Battery Metals is really, we don't use any type of brute force method like that. We do not have any high temperature operations. We don't simply dissolve the entire battery in a strong acid. Instead, because my background and that of my team is really in the design of the manufacturing processes of lithium-ion batteries. And like you mentioned, starting very early at the Gigafactory near Reno, designing how to actually manufacture these batteries, how to commission those production lines, how to decrease the defects and the manufacturing yield losses per stage. We've designed what we call a demanufacturing process, where within a matter of minutes, we can essentially take a full battery pack or set of modules or cells and physically deconstruct them in a strategic manner to physically separate them into scrap metals, into high metal powder materials, and then go through a much more strategic method of extracting each of those elements. And because we have this purpose-built system, we have significantly lower CapEx per throughput, much lower operating costs, and we're able to extract many more elements and at higher recovery efficiencies than existing processes. And that allows us to operate with a significantly higher margin, where we are not required to actually have companies pay us to take their waste away. And that really is encouraging and enabling so much more of this waste and end-of-life material to come back to us and to go back in the market in a circular fashion.
Okay, so I mean, I guess from our point of view, we write a lot about battery metals and this electric vehicle revolution that has been sort of slightly, well, I suppose people say different things about what's happened since COVID, but I mean, auto sales have gone down, but this sort of switch, certainly in Europe, to a greener to greener technologies, and there's been a real focus on electric vehicles. I mean, how soon might a technology like yours start to sort of factor into the battery side of things on an automotive on the automotive side?
It's a very gradual step for actually taking these battery metals and returning them back into the market. And every unit of recycled metal we send back in the market displaces 1 unit of otherwise sourced virgin metal. And the other part, like I mentioned, of many existing processes right now, they're only able to recover those elemental metals and purify them up to industrial grade. And many of them tend to be sold back into the stainless steel alloy market or the grease and ceramics market, and don't actually make it all the way back into the battery supply chain. And even though those materials are technically recycled, they really don't end up displacing battery grade metals that are in the existing supply chain. So as we work through that over the next few years, the rate will increase exponentially. Early on, a lot of our feed comes from consumer electronic type batteries, smartphones and laptops and tablets, and a very large amount from defects and manufacturing losses at cell and active material manufacturing sites. And as more and more electric vehicles start coming back from the market, that will also start to make an increasing percentage of our feed.
So, I mean, I guess if we take a step back and just bring in your background at Tesla, from what I understand, you effectively, sort of began the process of your technology or developing it at Tesla, and since leaving, you've continued on that journey. I mean, from what you say, it sounds like recycling is not something that the auto guys like Tesla are thinking about in the sort of short to mid term. It's a longer term play. But I mean, a company like Tesla, it really surprises me that they're not looking to develop it now, given that they're leading the way on EVs. I mean, do you think this is going to come back to bite them in the years to come?
The consensus now is that all of the major vehicle OEMs are much more focused on increasing the throughput on the manufacturing side, because the industry is still so supply limited. That's really where all their resources are being applied right now, to scale up that throughput as much as possible. So again, even the other US and European and Asian based recyclers, really tender automakers, seem to think that it's really not until end of life vehicles start coming back that they really need to focus on this type of technology. They're correct that that's when the throughput will grow dramatically, but you really don't want to wait until the throughput demand is really there before you start trying to develop a technology. So the plant we're building now, we're calling our first commercial pilot facility. It'll have a capacity of about 20,000 metric tons per year of feed material. That'll make it one of the largest lithium-ion battery recycling plants in the world, but it's still very small compared to the cell manufacturing capacity. And if we're ever going to move to a closed loop supply chain, the throughput of the manufacturing and the demanufacturing sides will have to be equal. So many of the large OEMs, yes, they are trying to wait for the commercial implementations and are not putting resources into the development at this stage. And each company has to make their own decisions, but we've really chosen to focus on this right now to scale up our operations in the near term and to really fill the void that exists in this industry.
Yeah, but of course you're also into the extracting side of, you're into the mining side as well. Can you talk a little bit about how that fits alongside recycling?
Yes, it's always surprising to me how few companies really understand the synergies of doing both of those together. When you look at either the recycling or the primary metal extractions, roughly the first third of those processing trains are really tied to the type of feedstock you're using. But once you get towards the middle and back end of those processes, once you're down to leachate, to leach liquor solutions, when you're going through aqueous purifications, when you're going to back end, hydroxide and sulfate conversion processes, and especially the laboratory analytics, the quality control, the supplier relations, all those completely overlap, whether you're starting with recycled material or virgin material. So us being able to spread out our R&D resources and potentially even some of our larger capital equipment to do the back-end processing from both recycled material and virgin material is showing huge gains in doing that in a much more synergistic design. And while the occupied mass of batteries in the field is going to continue to grow for many years, potentially decades, even with a 100% recycling recovery efficiency, we will keep having to add new material to that closed loop as it continues to grow. So both recycling and harvesting of elements from virgin feedstocks are required in order to support this industry.
Okay. Yeah, I mean, as you say, it is surprising that there aren't more people kind of thinking of covering those two bases. I just wondered if you've got any figures to hand on, or forecasts for how much the recycling side of things will impact on demand for battery metals further down the road. I'm thinking, towards the end of this decade or early 2030s, I guess, when the first sort of round of EVs are being scrapped or are coming off the road.
Right, so the throughput of recycling facilities is growing extremely quickly, but the cell manufacturing side is also growing extremely quickly. So within the next 10 years, we're forecast to see over a 10-fold growth in the annual manufacturing capacity of lithium-ion battery cells. So it's more of chasing a moving target. The recycled generated materials will continue to grow as we move forward, but they'll continue to be only a moderate percentage of total supply, really until we get to the top end of that S curve. And again, the total amount of EVs and stationary storage systems on the road starts to plateau. And that's really when the generation of recycled material starts catching up, and we don't have to add quite as much virgin materials into that loop.
Okay. Just a final one. I was just intrigued to know how leaving Tesla and going to work for a startup, how the two sort of compare. And I feel like at Tesla, you must have had a lot of resources at your fingertips to a lot of the smartest guys in the room type thing to develop this tech. Like, how's it been sort of going out on your own, I guess?
I mean, the answer is yes and no. When I joined Tesla back at the start of 2015, I specifically joined the Gigafactory team. So at that point, we hadn't even broken ground on the facility. It was still a patch of dirt out in the desert. So there were only about a dozen of us that formed, the Gigafactory team. We were really the only people in Nevada. The vast majority of the company was still down in the San Fran Bay area. So we pretty much felt like a startup company. We happened to be within a larger company umbrella, but those early days, we were very much a scrappy startup company. When I left, I feel like there were, I think a few days, there were over 10,000 people on site at Gigafactory, whereas early on there were a few dozen. So we really did grow as a startup into a much larger established entity within a larger company. And that's what we're doing here. I really do enjoy first of kind systems design, the rigorous modeling, the building of lab scale units, the validation of benchtop units, evolving that technology up to first of kind pilot units, and then building larger commercial systems. And then once the system is more mature and you're going through incremental improvement, I generally prefer to then start over again with a brand new technology and go back to a blank page again. So it feels great to be at the start of that curve again and just have so much opportunity in front of us.
Excellent. Well, yeah, it sounds like you've got a seriously exciting few years ahead of you. So, good luck with that. And hopefully we will speak again soon. But for now, that is all we've got time for. So thank you, viewers, for joining us. And we will see you again soon. Bye-bye.
Great to speak with you. Thank you.
Thanks, Ryan.